Hello, everyone, and welcome to this Sensata Technologies webinar. Now let me introduce today's presenter. With us today, we have Martin Posera. Martin is the Electrification Product Manager with Sensata Technologies. Also with us today is Alan Smith. Alan is the EVCC System Engineer Manager, also with Sensata Technologies. Gentlemen, with that, I'd like to welcome you to today's event and pass things along to you to get us started.
Thanks for the introduction, Katie. My name is Martin Poseiro, and today my colleague Alan and I will discuss about electric vehicle communication controllers, or EVCCs, and their critical role in electric vehicle systems. We both work for Sensata Technologies, who is a market leader in high voltage components and sensors that are used both in transportation as well as infrastructure applications. At Sensata, we support applications spanning from 400-volt automotive systems with short-circuit capacities of up to 20,000 amps to heavy-duty or heavy vehicles that can handle continuous currents of up to 3,000 amps. We are also in stationary applications such as electric vehicle charging stations or grid storage solutions with our Dynapower brand. In the automotive space, we offer many different sensors for the subsystems you can find in different electric vehicles. We also supply mission-critical safety devices such as fuses and contactors. On the other hand, in the heavy vehicle market, we offer a wide range of products for the high voltage systems, ranging from more complex components to more complex systems such as high voltage distribution units and electric vehicle communication controllers, or EVCCs, which is the focus of today's webinar. But what is an EVCC? There are a few acronyms to address this communication controller, but the most common out there is EVCC, which stands for Electric Vehicle Communication Controller. Another very common acronym is CCU, which stands for Communication Control Unit. EVCCs serve as a critical communication link between EVs or electric vehicles and the charging infrastructure, facilitating efficient, secure, and intelligent charging process. Their role is increasingly vital as the adoption of electric vehicles continue to grow, paving the way for a more integrated and sustainable transportation system. EVCCs sit on the electric vehicle and communicate with a sister controller known as SEC, which stands for Supply Equipment Communication Controller, which sits on the EVSE side or the charging station side. But let's break down why EVCCs are so important in the EV charging ecosystem. EVCCs are essential for the integration of electric vehicles into the broader ecosystem of charging infrastructure, enabling the vehicles to connect to public and private charging stations effectively. The EVCC ensures that the vehicle and the charger speak the same language, optimizing the charging process and preventing errors. Also, they enhance the overall user experience for EV owners by providing a seamless charging experience and enabling features like smart charging and vehicle-to-grid capabilities. Features like this make EV ownership more convenient and cost-effective, appealing to both individual users and fleet operators. Finally, they also collect data related to charging patterns, energy consumption, and vehicle performance, which can be used for future enhancement in vehicle design and infrastructure development. For example, in the heavy-duty industry, the EVCC gathers large volumes of data to help optimize fleet operations, allowing for efficient charging schedules and tracking of energy consumption across multiple vehicles, which in turn, of course, improves operation efficiency. Now we'll hand it over to Alan to talk about EVCC's key functionalities and components. Over to you, Alan.
Thanks, Martin. Hi, everyone. So I want to cover the main functionalities of an EVCC that particularly ties to IEC 61851 and ISO 15118. both critical standards for communication between electric vehicles, or EVs, and charging stations. I see IEC 61581 as the foundation of charging. It sets out the charging modes that range from basic slow charging to DC fast charging. For the EVCC, it details the support of the low level to the high level communication. The standard also defines power levels and connectors for each mode, specifying everything from voltage limits to current ratings. Again, for the EVCC, it defines what type of connector it will need to be configured for. For example, CCS1 or CCS2. Communication and control compatibility is essential. The standard supports communication between the EV and the charging station for monitoring and adjusting the power delivered. It is compatible with DIN 70121 and ISO 15118, which is particularly important for modes that involve DC fast charging. That moves nicely onto ISO 15118. So ISO 15118 is transforming the way EVs connect to the charging infrastructure by making the process, as Martin mentioned previously, smoother, smarter, and more secure. I'll focus on a number of key points. Plug and charge, which ties in automatic payment, charging session negotiation, security, and AC/DC charging support. First, let's talk about plug and charge, or P&C. How can I best explain it? Imagine pulling up to a charging station and simply plugging in your vehicle. No need to swipe a card or log into an app on your mobile. That's pretty much what plug and charge allows. Once the car is connected, it automatically identifies itself to the charging station, so there is no need for additional steps. This identification happens using a digital certificate stored securely in the EVCC, making charging as easy as plug and play. This feature not only simplifies charging, but also ensures that your vehicle is instantly recognized, streamlining the entire experience. On top of that, automatic payment takes that convenience even further. With plug and charge, the vehicle's digital certificate is linked to a payment account, enabling billing to happen automatically. As soon as charging starts, the system calculates the cost, whether that is based on time, power consumption, or a fixed rate, and then processes the payment without any extra steps from the driver. This automation saves users time, eliminates the need for multiple payment methods, and ensures a seamless charging process. Imagine the ease of pulling up, plugging in, and knowing the payment is handled without ever reaching for your wallet or your phone. Next, let's look at charging session negotiation, which makes charging efficient and customized for each vehicle's needs. Once the EVCC connects, it starts a negotiation process with the charging station to set the charging parameters. This includes things like the maximum power level, current, the other technical details that match the vehicle's battery requirements. The EVCC essentially tells the charging station how much power it needs and at what rate, while the station confirms if it can meet those needs. This not only makes charging faster and more efficient, but also helps protect the battery from overcharging or overheating. By ensuring that each session is tailored to both vehicle and charging stations' capabilities, the EVCC supporting ISO 15118 supports optimal charging every time. Of course, with all these automated transactions, security and encryption is critical. The EVCC, along with the standard, places a high priority on secure communication between the EV and the charging station. It uses transport layer security, or TLS, to encrypt all data exchanged during the charging sessions, preventing unauthorized access or data tampering. This means that personal and payment information is protected at all times. In addition to encryption, both the EVCC and the charging station authenticate each other with digital certificates, creating a highly secure, trusted environment for charging. Finally, and important to note, the EVCC can support both AC and DC charging. Electric vehicles often need to charge in a variety of situations, sometimes using a slow, steady AC current at home, and other times using fast, high-powered DC charging at public stations. An EVCC using ISO 15118 enables seamless communication across both AC and DC systems, so users can charge with ease no matter where they are. I talked a lot about the communication aspect of the EVCC, but it has other important components that complete the system. This block diagram represents both CCS and MCS charging, more of an overview of our next-gen EVCC development. The EVCC monitors the temperature of the charging pins around the inlet and will react accordingly to overtemperature events, ensuring that the charge cycle, whether it is AC or DC, will terminate safely. As talked about in the previous slide, low-level communication lays out support for the different charging systems according to IEC 61851. That covers CCS. For MCS, this is detailed in IEC 61851-23-3. The high-level communication for CCS is supported according to ISO 15118-3, using PLC as the physical layer of communication. For MCS, this has changed to use Ethernet according to ISO 15118-10. Locking motor control is also supported in the EVCC, with position feedback to ensure that the charge gun is locked into position before a charge loop can begin. Communication between the EVCC and the EVSC is translated and shared onto the vehicle CAN bus. This is critical as the main EV ECU needs inputs from the EVCC, the battery management system, and the onboard charger to provide the necessary information back to the EVCC for charging parameters and state of charge. The EVCC also supports LED output that can be used to indicate the state of charge to the driver. Back to you, Martin.
Thanks, Alan. Now we will talk about key criteria for engineering and sourcing teams. So let's start by differentiating the two most common on-road applications where EVCCs sit and what the differences are. When selecting an electric vehicle communication controller for passenger cars versus heavy-duty vehicles, the requirements vary based on their different needs. While both vehicle types need standard communication protocols and security, heavy-duty vehicles, such as buses and medium or heavy-duty trucks, require more robust and scalable features due to larger battery capacities, higher power levels, and greater operational complexity. So let's break down the differences. When it comes to power capabilities, as you can see on the left column, passenger car EVCCs are compatible with both AC and DC charging for home and public use. And they also support moderate power levels, typically up to 150 kW for fast charging. In turn, heavy-duty vehicles require that EVCCs can handle higher power levels, in some cases north of 500 kW, and higher voltage infrastructures of up to 1000 volts to meet their significant energy demands. In consequence, advanced cooling systems and features such as MCS or megawatt charging system are becoming more and more important for heavy-duty vehicles. Next is smart charging. Passenger cars EVCCs are increasingly expected to support V2G or vehicle-to-grid, as well as V2H or vehicle-to-home applications, as well as basic smart charging features to optimize costs and user convenience. EVCCs in cars often come with smart charging features that allow the vehicle to charge during off-peak hours to save costs, making it more user-friendly and cost-efficient. On the other hand, heavy-duty vehicles require more advanced V2G functionalities to support energy balancing for large-scale deployments, which in other words, allow for fleet operators to maximize energy use by drawing from vehicle batteries during the demand surges on the grid. Moreover, fleet operators EVCCs must support for advanced scheduling capabilities to benefit from scheduling, charging, and energy optimization based on operational hours. Next, in regard to durability and environmental resilience, passenger cars require EVCCs that are designed for more standard conditions, handling a wide temperature range but not needing for extreme robustness. For instance, plastic enclosures and standard cooling features are more than enough for passenger cars. On the other hand, heavy-duty vehicles EVCCs must be highly durable, supporting ingress protection or IP code systems, which classifies and rates the level of protection offered by enclosures. In this case, IP67 ratings or higher, enabling to withstand extreme conditions like vibration, dust, and moisture in harsh environments are needed. Finally, in terms of communication capabilities, passenger cars, EVCCs, generally only require standard communication protocols like ISO 50118 or IEC 61851, along with a CAN interface to connect with other ECUs, which are sufficient to meet most needs. Alternatively, for heavy-duty vehicles, the EVCC communication protocols need to support more extensive data management, of course, fleet integration, and diagnostics. Some examples of these protocols are ISO 50118-20, which is an advanced version of the ISO 50118, SAE J1939, a communication protocol based on CAN specifically designed for heavy-duty industry, as well as a high-speed CAN communication. But not all EVCCs, or electric vehicle communication controllers, are built equally. A high-quality one with the right features can significantly reduce the total cost of ownership, or TCO, for electric vehicles by extending battery life, lowering infrastructure and maintenance costs, optimizing energy use, and supporting smart energy management. To extend battery life, EVCCs work closely with the battery management system, or BMS, to regulate charging and prevent battery degradation. They use optimized charging profiles that minimize battery stress, which helps prolong battery life and delays the need for costly replacements. EVCCs also include state-of-the-art health monitoring to detect potential battery issues early, preventing expensive repairs. Reduced charging costs are another key benefit. With AC-DC compatibility, high-quality EVCCs support various charging types, reducing the need for specialized equipment. Features such as plug and charge automates payment, eliminating the need for additional hardware, while interoperability ensures compatibility with different charging networks, making the vehicle less reliant on specific chargers. Additionally, smart charging capabilities allow EVs to charge during optimal times, such as off-peak hours, to reduce energy costs. Dynamic load management further contributes by adjusting charging rates to prevent grid overload and minimize demand charges. Maintenance and downtime are also minimized through features like preventive diagnostics, which continuously monitor the vehicle's electrical and charging systems to avoid costly breakdowns. Update capabilities allow firmware updates, enhancing performance and resolving issues without requiring a service visit. Reliable communication with charging stations reduces downtimes and prevents common charging issues. In terms of energy saving, advanced EVCCs support vehicle-to-grid or V2G integration, which enables EVs to send energy back to the grid, earning credits or offsetting energy costs. Features like energy arbitrage allow fleet operators to buy electricity at low rates and sell them back at high rates, reducing lifetime energy expenses. Participation in demand response programs helps lower electricity costs by adjusting consumption during peak hours. Improved fleet management is another major advantage. With optimized charging schedules, EVCCs ensure efficient charging while minimizing unnecessary battery cycles, which of course reduces operational expenses. Centralized management features allow fleet operators to monitor and control charging activities across all vehicles, simplifying operations and reducing costs. Additionally, real-time energy use monitoring enables cost-saving strategies, such as off-peak charging. By leveraging all these features, a high-quality advanced EVCC can effectively lower operating costs and boost overall vehicle efficiency, making it especially valuable for fleet operators. Next, we will talk about upcoming trends and innovations expected in EVCCs. Starting with evolving charging standards. As electric vehicle adoption grows, two major concerns for both fleet and consumer vehicles are driving range and charging times. To address range limitations, original equipment manufacturers, or OEMs, are equipping vehicles with larger battery capacities. For instance, some certain passenger vehicles now exceed 200 kWh, and some Class 8 trucks, electric trucks, now feature battery packs of up to 900 kWh. These larger batteries are designed to enable truck drivers to cover the same distances within a shift as they would with an internal combustion engine, or to allow families to take long trips without needing frequent stops to recharge. However, larger batteries come with a trade-off. They take longer to charge, which presents its own challenges. In response, the passenger car, light commercial vehicle, and medium-duty markets are aiming to create a more streamlined and widespread charging experience. Many manufacturers are shifting toward the North American Charging Standard, or NACS connector, formerly Tesla's proprietary connector, as their primary solution. This standardization effort has the potential to eventually replace the CCS or combo charging format across the North American region, providing a more consistent user experience and improving the charging network for everyday drivers. On the other hand, the heavy-duty and industrial vehicles are turning into the megawatt charging standard, or MCS, to tackle the need for faster, high-capacity charging. MCS enables ultra-high power levels, significantly reducing charging times and allowing for rapid recharging, of course. For example, during the mandatory lunch breaks, a heavy-duty truck could quickly gain enough range to complete its route or meet operational demands. This solution is particularly valuable for fleet vehicles, where minimizing downtime is essential for maintaining productivity. This evolving landscape of charging standards reflects the industry's dual approach to accommodate different types of EVs, ranging from daily consumers vehicles to high-power, long-haul trucks, each with unique range and charging requirements. Another major advancement currently in development within communication standards for electric vehicles is ISO 51108-20, which is an evolution of the earlier ISO 51182 standard. This new version focusing on enhancing the communication between electric vehicles and charging stations. As the automotive industry continues its shift towards electrification, this standard is set to play a vital role in strengthening charging infrastructure to meet emerging needs. The significance of ISO 15118-20 is substantial due to its contribution to multiple aspects of EV charging. First, it improves user experience through features such as plug and charge, which simplifies the charging process by enabling automatic authentication and payment without the need for apps or RFID cards. This seamless experience removes complexity, allowing users to charge their vehicles effortlessly, making EV adoption even more appealing. Another crucial aspect of ISO 15118-20 is its focus on cybersecurity, as it introduces robust security protocols, including support for TLS 1.3. TLS 1.3 is a cutting-edge encryption protocol that protects data during transmission between EVs and charging stations. In addition to enhancing usability, ISO 15118-20 introduces features aimed at cost efficiency and grid stability. Through smart charging capabilities, it enables vehicles to charge during off-peak times, helping consumers save on energy costs. This standard also facilitates bidirectional power transfer, or BPT, allowing EVs to return energy to the grid during peak demand times. This capability not only supports individual cost savings, but also helps balance the grid, thereby contributing to a more resilient and stable energy system. The standard further supports the integration of renewable energy into the grid by enabling EVs to participate in energy management systems. ISO 15118-20 promotes the alignment of EV charging with times when renewable energy sources like solar or wind are abundant. This aligns EV charging with sustainable energy goals, enhancing the environmental benefits of electric transportation. Finally, ISO 15118-20 offers a level of future-proofing for charging infrastructure. As demand for electric vehicles grows, having standardized communication protocols that support advanced functionalities will make charging networks more versatile and ready for future demands, of course. This forward-looking approach not only benefits consumers, but also appeals to investors by enhancing the long-term value and functionality of EV infrastructure. In summary, ISO 15118-20 is pivotal in advancing the efficiency, convenience, and sustainability of EV charging systems, supporting a broader shift towards electric mobility and helping to create a resilient, user-friendly, and sustainable charging ecosystem. Some of the key features of ISO 15118-20 are cybersecurity TLS 1.3, bidirectional communication or bidirectional power transfer, and plug and charge, like I just mentioned before. Now we'll hand it over to Alan to elaborate on these three key features around ISO 15118-20. Over to you, Alan.
So just to reiterate what Martin talked about, with new features and advancements in plug and charge within ISO 15118-20, there is need for more secure communication between EVs and charging stations. Where TLS was optional in ISO 15118-2, it becomes mandatory in ISO 15118-20. Enter TLS 1.3. But what does it mean? The latest version of Transport Layer Security, TLS 1.3, provides robust encryption for data exchange between the EVCC and the charging station. It is faster, more secure, and more efficient than its predecessor used in ISO 15118-2, making it the ideal choice for protecting communication in EV charging. So, how does TLS 1.3 work in this context? First, it establishes secure encrypted connection by performing a quick handshake between the vehicle and the charging station. Unlike earlier versions, TLS 1.3 completes this handshake in a single step, which means that the connection is both faster and secure. This efficiency is important, especially in charging networks, where minimizing delays in setting up secure connection can make a big difference for user experience. TLS 1.3 also enhances security by eliminating outdated algorithms that were vulnerable to attacks. It uses advanced encryption standards and perfect forward secrecy, meaning that even if someone were to access a session's data, it wouldn't compromise future sessions. This is critical for protecting user information and keeping payment data secure from potential attacks. Additionally, TLS 1.3 ensures mutual authentication. Both the EVCC and the charging station validate each other's identities using digital certificates, creating a trusted, verified connection on both sides. This mutual trust is essential, particularly for the plug and charge feature, where sensitive data needs to be exchanged automatically and reliably. So in summary, ISO 15118-20's integration of TLS 1.3 creates a faster, more secure and future-proof standard for EV charging. By combining advanced encryption, faster handshakes and mutual authentication, this standard ensures that as EV adoption grows, charging remains a safe, seamless experience. Next, I want to talk about bidirectional power transfer. As Martin mentioned, as we move toward a more sustainable energy landscape, electric vehicles will need to play a critical role. They can serve as portable energy storage units that contribute to our overall energy grid. This is where bidirectional power transfer comes in, which allows energy to flow both ways, not only from the grid to the vehicle to charge it, but also back from the vehicle to the grid, to homes, or even to other loads when needed. ISO 15118-20 is key for enabling this two-way interaction. It introduces a unified framework for bidirectional charging, setting guidelines for communication between the EVCC and the charging infrastructure. With this standard, there are several key capabilities. So through vehicle to grid, EVs can send power back to the grid during high demand periods, helping to balance energy loads and prevent blackouts. This makes EVs a flexible grid resource, especially as renewable energy resources like solar and wind bring more vulnerability to our energy supply. Vehicle to home. So imagine using your EV as a backup power source during a home power outage, or reducing household electricity costs by drawing electricity from your EV battery during peak hours. In emergencies, this can make EVs essential for home energy resilience. For more specific uses, such as powering an outdoor equipment or even camping, vehicle to load allows you to use energy stored in your EV battery for individual devices and applications directly. But there are challenges. Bidirectional power transfer introduces added complexity and has implications for battery health. Frequent charge and discharge cycles can impact battery life. Hopefully, as the technology matures, battery management systems are expected to evolve, and standards like ISO 15118-20 will help optimize these cycles, balancing usability and battery longevity. I touched upon plug and charge earlier in the presentation, so I won't spend a lot of time on this slide. This is not a new feature, but more of an advancement in plug and charge within ISO 15118-20. The key advancements in plug and charge is that it operates on TLS 1.3, making data exchange more secure. The size of the plug and charge certificate has also increased from ISO 15118-2. This will improve security. But the main difference for the user is tied to billing. With ISO 15118-2, plug and charge only supports one contract. The move to ISO 15118-20 It is now possible to hold multiple plug and charge contracts. This can be tied to different billing accounts or providers and gives more flexibility to the user. It also provides a backup if there is an issue with installing or updating a contract that has been expired. I'll hand it back to you, Martin.
Thanks, Alan. That was really interesting. Now, let's talk about Sensata's EVCC features and roadmap. What does Sensata's EVCC have to offer? Our current generation EVCC is a proven customer configurable product designed to ensure seamless integration and communication between EVs and charging stations. Let's take a look at the key features, starting from top left. Sensata's EVCC includes AUTOSAR embedded software. AUTOSAR standardization allows for interoperability with other systems, which helps with scalability and ensures long-term reliability and support for automotive software. It also complies with important communication industry standards. These standards ensure that the EVCC meets all necessary technical and safety regulations, allowing for reliable and standardized performance, as previously covered by Alan in detail on previous sections. Our EVCC supports plug and charge, or PNC, in line with ISO 5118-2. As explained before, this feature allows the EV to connect to the charger and begin charging without additional user input, making the experience seamless and convenient. Sensata's EVCC is built with a robust enclosure that's both durable and reliable in various environments. It operates within a wide temperature range from -35 to +85 degrees Celsius. Plus, it has high IP protection ratings, meaning it's resistant to water, dust, and harsh conditions. It also meets stringent functional safety targets designed according to ASIL-B standards. ASIL-B, or Automotive Safety Integrity Level B, is crucial in the automotive industry to ensure that all safety-critical operations are reliable and secure. Next, it supports both CCS1 and CCS2 charging standards. CCS, or Combined Charging System, is a widely adopted standard. So this compatibility means that our EVCC can work with the vast majority of charging stations globally, specifically in Europe and in North America. Lastly, our EVCC supports high-speed CAN communication, specifically CAN 2.0. These allow reliable data exchange between EVs and charging stations, ensuring that information flows smoothly during the charging process. To summarize, our EVCC brings together a comprehensive range of features, from robust design and high safety standards to a broad compatibility with major charging standards. All of this makes it a powerful solution for seamless EV charging communication. But what about our roadmap and plans for the future? We are excited to announce that our next generation EVCC products, generations 2 and 3, will be launched in 2025, with samples available for our customers earlier in the year. Generation 2 builds on the success of our current generation EVCC, incorporating all the proven features of the first generation. In addition, we are introducing new capabilities such as support for the North American Charging Standard, or NACS, ISO 5118-20 compliance with bi-directional power transfer, or BPT, and enhanced cybersecurity with TLS 1.3, features whose importance we have discussed in the previous section. Looking further ahead, Generation 3 will be built on top of Generation 2 and will be specifically designed to support the megawatt charging system, or MCS, to meet high power demands of heavy vehicles, including both on-road and off-road applications. Lastly, let's take a moment to discuss the two types of products we support at Sensata. The first is our off-the-shelf product, which we just covered. Currently, we offer generation 1.5, with generations 2 and 3 set to be available soon. These off-the-shelf solutions are ready-made, high-quality products that can be quickly integrated into the customer system. To enhance the experience, we also offer an application engineering team dedicated to supporting these products. This integration team is crucial in providing a superior customer experience by offering tech support, troubleshooting assistance, and gathering valuable feedback for continuous product improvement. On the other side, we offer customized solutions tailored to the specific needs of leading OEMs. For these projects, we work closely with customers to develop bespoke solutions that align with their unique requirements. This customer-centric approach allows us to create a system that seamlessly integrates with the customer's existing architecture, minimizing the need for further development on their end. The result is a tailored solution that not only meets but often exceeds the customer's expectations in terms of compatibility, functionality, and efficiency. In summary, whether through our flexible, ready-to-deploy off-the-shelf product or our bespoke customized solution, our goal is to provide our customers with high-quality, reliable options that support their unique needs and help them achieve success in their market. Thanks for listening so far. To summarize, let's go over some of the key takeaways of the webinar. Starting from the left, we discussed EVCC and its importance in the EV charging ecosystem. EVCCs are essential for enabling secure and efficient communication between electric vehicles and charging stations. We also talked about its key functionalities. As discussed, EVCC offer various functions to successfully manage and enhance this communication. Next, we touched upon different requirements customers have depending on the customer needs or the application where the EVCC sits. Understanding the unique requirements can help reduce the total cost of ownership, or TCO, by selecting the right system for each vehicle type. Finally, we reviewed some of the key trends and innovations surrounding EVCCs, where upcoming features such as bidirectional power transfer and enhanced cybersecurity, as well as evolving charging standards like NACS or North American Charging Standard and MCS or the Megawatt Charge System, will have a more prevalent role in the future.
Gentlemen, thank you both so much for that great presentation. So we do have a couple questions that we're going to take from our audience at this time. All right, gentlemen, so our first question in the queue today is, can you give us some customization examples you do at Sensata with your EVCC?
Yes, customization-wise, we can develop from customer-specific requirements. This might be implementing customer-specific CAN signals, diagnostics, or changing the behavior of the EVCC on the EV interface side. How peripheral devices are managed or monitored. So, for example, the inlet control or the LED functionality. Customers might have specific safety goals that need to be met, or cybersecurity requirements that need to be implemented. These are some of the examples that we support. Thanks.
All right, thank you so much for that answer. So next question in our queue here. Can Sensata EVCC be used in BEV retrofit applications? For example, in D2E conversions?
I'll take that one, Katie. Thanks for the question. The short answer is yes. Our EVCC can be used in battery electric vehicles retrofit application, including diesel to electric conversions. As you all know, the retrofit industry is growing rapidly, with more and more companies looking to convert those existing diesel vehicles, especially those older heavy-duty vehicles like buses, trucks, and construction equipment, into fully electric models. During these conversions, all diesel components are removed and replaced with electric powertrain components, including the EVCC, which is, as discussed before, essential for enabling secure and efficient charging of the new battery system. Most companies in this space are seeking for a cost-effective, reliable, and readily available solution, making our off-the-shelf EVCC a perfect fit. Why? Because it meets the unique requirements of the retrofit industry and helps streamline the electrification process, bringing older vehicles up to modern electric standards.
All right, next one here. You talked about plug and charge during the presentation. How are the certificates managed and used?
Yes, good question. Thank you. So there are a number of certificates, private keys needed to operate plug and charge. There is a root certificate needed, an OEM provisioning certificate, at least one plug and charge sub certificate, and a plug and charge contract certificate. Now, there are a number of use cases where the contract certificate can be installed or updated, and that is via the charge protocol itself, or with our EVCC, it is possible to install the contract certificate and the other certificates via UDS. So hope that helps. Thanks, Katie.
All right, thank you so much for that answer. So we do have time for a couple more questions today. For all of our audience members, if you have a question for us today, feel free to enter it into the Q&A window and click submit. If you don't hear your question being answered, we will reach out to you following today's webinar. All right, gentlemen, our next question here. Can your team support customer configurations for off-the-shelf products?
That's a great question, Katie. Thanks for that. And thanks to the audience for such an engagement. So I'll take that one. And so as mentioned earlier, our off-the-shelf product is fully configurable to meet specific application needs. So we essentially offer two options for configuration. You can either customize the settings yourself using the tools we provide, such as a user manual, a very extensive user manual where you can find all the different parameters you can customize, or we can do it for you, and we can do that configuration for you at a cost. Some examples that I can think of top of my head that are configurable, for example, is the CON baud rates and message cycle times, value-added services, charging schedules, OEM provisioning certificates for plug and charge, etc. There are quite a few out there, but again, we can do it for you at a cost, or you can do it yourself. It's also pretty easy, I would say, since we provide all the tools and all the explanations necessary on the user manual. But again, this is a configurable product that allows you to integrate the EVCC seamlessly into any application out there that you may be thinking of. I hope that helps answer the question. Back to you, Katie. Thanks.
All right, gentlemen, this is going to be our last question for today. This person is asking, is it possible for the EVCC to support both ISO 2 and ISO 20 protocols?
So I can't speak for other EVCCs in the market, but regarding our next-gen EVCC, the answer is yes. So we will support ISO 15118-20-2 and the DIN standard. There is a priority order set within the ECU logic. Therefore, depending on what is supported at the EVSE, our EVCC will fall back to that protocol. So, for example, I arrive at a charge point that only supports ISO-2. Our EVCC will check for ISO-20 before falling back and checking for ISO-2. If the charger only supports the DIN standard, then the EVCC will fall back again to support DIN. I hope that helps answer the question. Thanks.
All right, gentlemen, we are going to wrap the webinar up right there. So first, I want to say a huge thank you to Martin and Alan for a great presentation and for answering a few of the attendees' questions. Take care, and we will speak with all of you soon.